You stop eating, you stop moving, your body barely ages, and a few months later you wake up on Mars. This isn't a movie. NASA is actually working on this, and the secret has nothing to do with rockets or fuel. It's sleep. Scientists are figuring out how to keep astronauts unconscious for months alive, but barely the science behind it will change everything which we know about the human body. But before we begin our journey to Mars, let's start with a short story. Once upon a time in 1995, a 4-year-old boy fell through a frozen lake. His body temperature dropped dramatically, and his heart stopped beating for 88 minutes. Doctors almost gave up on him, and his family lost all the hope. But then something extraordinary happened. When doctors slowly warmed his body, his heart started beating again, and just 2 weeks later, he walked out of the hospital with no permanent brain damage. The extreme cold has slowed his body's processes so much that it protected his brain and organs from dying. So was this a miracle or a hidden survival mechanism of the human body? Let's find out. This real-life incident sparked a question among scientists. What if humans could survive long journeys at low temperature without dying? That's why the idea of sleeping through space has shown up in science fiction for generations. And what's remarkable is that many ideas once considered pure fiction have eventually become the reality. Today, scientists are seriously exploring one such concept: cryosleep. But why do we actually need it? The answer lies far beyond Earth. Humans dream of exploring the solar system and eventually reaching the distant stars. Our first major target is Mars, the journey that roughly takes 6 to 9 months. But Mars is only the beginning. Future missions to other star systems could take decades or longer. And that's where a serious problem appears. Humans are not easy cargo. We need food, water, oxygen, radiation protection, and enough space to maintain mental and physical health. The longer the journey, the more expensive and difficult it becomes to keep astronauts alive. These limitations could slow down humanity's expansion into space, and this is exactly where cryosleep enters the picture. The idea is simple: place the body into a deep sleep, slow everything down, preserve it, and wake the person safely in the future. If this ever works, it won't just change the space travel, it will change humanity, medicine, and survival itself. Now, when people talk about cryosleep, they usually mean one of two things: cryonics or torpor. Cryonics is the practice of preserving a person after legal death, hoping that future medicine can revive them and cure whatever killed them. Fascinating idea, right? But here's the problem: no human has ever been successfully revived in this way. No one has come back. It remains entirely theoretical. And that's not NASA is chasing. What scientists are actually focused on is something different. Something that nature has already proven and tested. It's called torpor, a temporary state where body slows its vital functions, heart rate, breathing, metabolism. Not to freeze, not to die, but to simply wait. And here's the thing: nature has been doing this for millions of years. The evidence of torpor doesn't come from a lab, it comes from nature. Bears are one of the most remarkable examples. When they hibernate, their body metabolism drops by nearly 75%. They can survive 7 to 8 months without drinking or eating anything. And despite months of complete inactivity, they lose very little muscle strength. Now compare that thing to humans. Just a few months of bed rest can cause us to lose more than half of our muscle strength. This gap is enormous. And it raises a critical question: how do bears protect their bodies so effectively? Scientists are also studying the fat-tailed dwarf lemur, the only hibernating primate, to understand how an animal more like us survives and shutting its body down for so long. But the deeper mystery is, what actually switches hibernation on? Researchers believe the answer may lie in a tiny brain receptor called the A1 adenosine receptor in animals like Arctic ground squirrels. Activating this receptor can trigger a hibernation-like state, almost like flipping a hidden switch. But the question is whether humans have a similar switch. So far, scientists don't know. Human biology is far more complex, and many of these internal mechanisms are still not fully understood. But these natural examples precisely why researchers believe human torpor isn't impossible, just unsolved. And to make this possible, NASA funded a company, SpaceWorks, which developed one of the most detailed proposals for using topper in deep space travel. The concept is, instead of staying awake for the entire 6 to 8 months journey to Mars, astronauts would spend most of it in a medically induced torpor state. Body temperature lowered at around 32 to 34 centigrade. Metabolism significantly slowed, everything working at a minimum. During torpor, astronauts would receive liquid nutrition through feeding tubes, while automated systems continuously monitor heart rate, blood pressure, oxygen levels, and body temperature. And to handle emergencies, SpaceWorks proposed something called Sentinel Protocol, a rotating sleep system. Instead of putting the all crew under all at once, most astronauts remain in torpor for roughly 2 weeks, while one crew member stays awake to monitor the spacecraft. Then they rotate. If someone needed to wake up early, the process would be gradual. The body is slowly warmed, medications stopped, and support systems removed. According to SpaceWorks, torpor could reduce habitat mass by more than 50% and cut food, water, oxygen requirements by up to 70%. That means smaller spacecraft, lower launch costs, and missions that are actually practical at scale. There's also a benefit scientists didn't fully expect: radiation protection. Outside Earth's magnetic field, astronauts would expose to dangerous cosmic radiation. Scientists have proposed the hypothesis that torpor may protect those radiations due to slowed body systems and lowered body temperature. The European Space Agency (ESA) is also exploring torpor for future Mars missions, studying how reduced metabolic states could make long-duration spaceflight more practical. Torpor sounds promising, but the obstacles are real. When the body cools, blood thickens and becomes harder to circulate, increasing the risk of clots and reducing the delivery of oxygen to vital organs. Long periods of inactivity can cause muscle and bone loss in humans, in ways hibernating animals somehow avoid, and there is no approved drug currently exists that can safely place a healthy human body into torpor for months. And then there's the freezing problem. Unlike cryosleep in movies, you cannot simply freeze a human body. Freezing creates ice crystals, and those crystals rupture cells, damage organs, and shred delicate brain tissue. Scientists are also exploring a technique called vitrification as a potential solution. Instead of freezing, vitrification turns the water inside cells into a glass-like solid state. No sharp crystals, no tearing. Molecules stop moving, everything holds in place, and the structure stays intact. Scientists have successfully vitrified embryos and small tissues, but no human brain has ever been preserved and revived in this way. And the brain is the hardest problem of all. It contains roughly 86 billions of neurons connected by trillions of synapses, storing memories, personality, and everything that makes you you. Even if the body survives months of torpor, scientists still need to prove those connections remain completely intact when the person wakes up. And that question has no answer yet, and that is a horrible reality. So can humans really sleep their way to Mars? Right now, no, not yet. But here's the thing what's true. NASA and ESA are actively funding this research. Hibernating animals is already proven. That deep metabolic slowdown is biologically possible. Vitrification is advancing. At what once existed only in science fiction is now being seriously studied in the laboratories around the world. And maybe that's the most exciting part. We are living in the moment just before this becomes real. The generation watching this video might be the same generation that books a ticket to Mars and doesn't think twice about a nap in between. The gap between science fiction and science fact is closing, and when it finally closes, the journey to another planet won't begin with a launch, it will begin with a nap. If you enjoyed exploring the science behind cryosleep, subscribe and join this journey of curiosity. Because there are countless mysteries hidden in space, science, and the world around us. And together we'll keep finding the X. Until next time, stay curious.